Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve these two problems, and these two problems are similar to each other. So problem 279 says that determine the magnitude and direction of force F, and we are given the Cartesian vector representation of force F. So we can find the magnitude of this force F by applying the Pythagoras theorem. So we can say that force magnitude, this is problem 279 solution. So the force magnitude is 690 square. We will take the squares of all the components. So this is f of x, this is f of y, and this is f of z. So 690 square plus 300 square plus 580 square, and then we will take the square root. That's the Pythagoras theorem. So this will give us 950 pounds. Let's find it. This is 690 square plus 300 square plus 580 square. This is 950 pounds. So the force magnitude is 950 pounds. Further, we are asked to find the direction of the force F. We need to find the angles of this force F with the positive x, y, and z axis respectively. So we need to find theta x, theta y, and theta z. So we are required to find theta x, theta y, and theta z. So now if I draw these components, the x component of force F is 690 pounds, and that is acting in the positive I direction. So this is plus 690 I. So that 690 pound component Fx will be acting in the positive x. Then we have 300 in the positive j, so that is 300 in the positive j, and then we have 580 in the negative z. So this is our negative z. So now let's draw those components. So we will have the x component like this. This is f of x. Then we have f of y. F of y is 300. So this is f of y, and then we have f of z. This is f of z. This is f of z. And as we know that the sum of these three components by head to tail rule, they must give us the force F. So this one is, this is f of y. This is f of y, this is f of z. So now if I add these three components by head to tail rule, so let me copy this f of y. So this is f of y that must be acting here. First let me copy fz. So copy. So this is fx, this plus fz plus fy. The order doesn't matter, right? We can add them in any order, right? So this is f of x, this is fz, and this is f of y, and the resultant will give us the force F vector. So this is that force F. This is that force F vector. Now I will erase these components. We got this f of x. Now this f is making angle theta x with the positive x. It is making theta y with the positive y, and it is making theta z with the positive z. So now from this we can observe that theta x must be less than 90, theta y must be less than 90, and theta z must be greater than 90. Now if I drop a, let's say if I drop a perpendicular from the head of this force F to the head of this f of x, let's say that this pink line is perpendicular to that f of x. So this will give us, this will be a right angle triangle then. And as I have told you people that this force F is making theta x with the positive x. So this will be theta x. This is theta x. Now, as we know that if this is theta x, this f of x is adjacent with this theta x angles. So this f of x is the cos component. So we can say that f of x is f cos of theta x. Similarly, if I drop a perpendicular from this force F onto the head of f of y, let's say if we drop another perpendicular like this, and if this is here, if this is making 90-degree, and now if we consider this right angle triangle, right, this plane, so then this angle is theta y. Let me represent this angle. This angle is theta y. Then f of y is adjacent to theta y, then f of y will be f cos of theta y, right? So we can say that f of y is f cos of theta y. And then if I drop in another perpendicular from the head of f to the head of f of z like this, and then we consider, if we consider this, let's say if this is another right angle triangle, if we look from this side, so this will look like a right angle triangle, and then this angle is the angle with the negative z axis. So let's say if I call this angle is theta z dash, since the angle with the positive z axis is theta z, right? So let me show that angle, and that angle with the positive z axis is theta z. Then this f of z will be, again, this is adjacent to theta z dash, so we can say that fz is f cos of theta z dash. But then while using this right angle triangle and this theta z dash, we will be using the positive value of fz. So then we will be able to find theta z dash. If we use the negative value of fz, since fz is minus 580, then we will be able to find this theta z, this angle with the positive z axis. And so now we want to find the angle with the positive z axis. We need to use this fz magnitude as the negative value. So that means that the f of x, f of y, and fz, they can always be represented as the cos components if we are given theta x, theta y, and theta z angles with the positive x, y, and z, right? So we can write that. So there is no need to draw all these perpendiculars. So I have drawn all these just to demonstrate that how f of x, f of y, and fz are the cos components. So while solving such problems, we can always consider f of x, f of y, and f of z as the cos components in terms of theta x, theta y, and theta z. So now we need to find theta x. So from this, from these three equations, we can say that cos of theta x is f of x divided by f, or we can say cos of theta x is f of x divided by f, or we can say that theta x is cos inverse f of x divided by f. And similarly from this we can say that theta y will be cos inverse f of y divided by f, and similarly cos of theta z will be f z divided by f. Now just putting the components and the magnitude, we can find theta x, theta y, and theta z. So cos inverse f of x is 690 pounds, 690 divided by 950. Theta y will be the y component, cos inverse of the y component. So the y component is 300 pounds. So 300 divided by 950. And the z component is f of z. Now we are going to use the negative value. So that is minus 580. So minus 580 divided by 950. So now we will be able to find all the angles. So cos inverse 690 divided by 950. This gives me theta x 43.42 degrees. This is less than 90 degrees. And similarly, theta y will be 300 divided by 950. So that is 71.59 degrees. And similarly, theta z is minus 580 divided by 950, so that is greater than 90 degrees, so that is 127.63 degrees. So now the magnitude of that force F is 950 pounds, and it is making 43.42 degrees with the positive axis, 71.59 with the positive y, and 127.63 degrees with the positive z. And similarly, using the same method, we can find the magnitude by applying this equation, and then considering these three equations, we can find the direction of this given. So this is the solution of this particular problem. I hope you guys will solve the second problem yourself and will post the answer in the comments. Do subscribe Engineers Academy for the solution of such more problems from vector mechanics by Beer and Johnston.